Alrighty. Hi everyone, thanks for joining today. My name is Bojan Živic. I'm one of the co-organizers along with Ilya and Carl of the Brisbane Serverless Meetup. So to give you a summary of what we're here today, we're here to discuss all things serverless across all the various different clouds. Some do it better than others. AWS is the best. Anyway, and we're going to be diving into some things first. First, thank you to Mantel Group for hosting the space, providing the soon-to-be pizza. And if we're in the middle of a presentation, we'll probably have a pizza break straight afterwards. And obviously the beer's in the fridge. And then let's dive into news straight away. So AWS. First of all, we've got EventBridge now supporting customer-managed keys. One of the big things we found is, depending on the organization, they don't want to just rely on defaults. They want to have their own. They want to deal with the resource policy side. So AWS gives you the option. Another one is that OpenSearch Serverless is now using smart caching. I don't want to focus on that. If you haven't known, OpenSearch is now officially open source. So after taking the inspirations from Elasticsearch all those years ago, AWS has decided, much like it did with Carpenter for the Kubernetes people amongst us, to give the open source community OpenSearch. So step in the right direction. Validation API for step functions. You don't have to create your own validation API now. You can actually utilize the state machine to do that instead. Again, mentioning open source. That's a win for everybody. Now you've got filter criteria encryption for event sourcing on Lambda. And the one that I like, because I've seen this hit many times for me, is the EventBridge scheduler now provides a higher default service quotas. One of the downsides with going completely event-driven, as some portions of business do tend to go, is that the innate cloud-native quotas can be a bit of a limitation if you're not aware of them. Having higher quotas means that we can actually do more with this same amount of product effectively. My assumption is AWS probably got more hardware in and said, hey, we can scale higher. Let's give people more options. Lambda now supports function-level configurations for recursive loop detection. I like this because, much like you, I hope this is the case. I'm assuming nobody's perfect here, right? No hands? All right, cool. I've created recursive loops in my code, and it's good to know that not just my PRs are going to get checked. AWS will tell you, well, hold on. Your Lambda function is going to run forever, and it'll actually cost you money, or 15 minutes. It'll actually check that now for you. So it's a good check yourself before you wreck yourself sort of scenario. Going on with that, step functions now support customer managed keys. This is a theme that we're seeing more and more of. I think everywhere now that you see a default set of encryption without the mention of using KMS, AWS is going to go take a step forward and say, hey, we're going to give you the ability to use custom managed keys in one form or another, mainly because people want control of what they work on. They don't want just to trust, Big Daddy Amazon and go, hey, Mr. Bezos, you encrypt everything. I trust you. And then finally, one that I like for the Java people here. Anyone use Java? One, probably a couple. It's all right. I didn't put my hand up too high either. Snapstart now works on ARM. What that means is if you're using Lambda functions with Java, and you can utilize Snapstart, which is where Lambda functions, or rather, sorry, let me explain this better. A snapshot is taken of the just-in-time compilation for Java. At that point in time, it will be saved as a snapshot, snapstart, and then instead of having to run through the full invocation when you're running a Lambda function in Java, instead, it runs at that JIT time, so meaning that the cold starts are effectively close to dead, and especially for something as heavy as Java, that's awesome. But now it's cheaper using ARM, in other words, Graviton. On to Azure. Azure, first of all, a lot of the Azure services come from the container apps, but you don't have to manage them. Onto the Azure side, Java's now available on Azure Container Apps, generally available, which is what I like, so no more limited to specific regions. They had a ton of public previews, so I've prefaced those. Azure Web Pub Sub, so this is Azure's equivalent to EventBridge. They've given MQTT support. Anyone know here what MQTT is? It's still used. So what MQTT is, it's a messaging protocol that's used by, first of all, quite a lot of IoT devices still to this day, and quite a lot of applications now. It's not just using the specific SDKs, like, for example, using EventBridge. And having that availability means that you can do more with it. But public preview, so give it 6 months before it's fully baked. General availability, Webpub Sub is the event-driven bus for Azure to use what they call messaging and queues. So if you're doing event-driven stuff, so asynchronous applications and such, the AWS equivalent is EventBridge. Yeah. Azure Functions now support PowerShell 7.4. We threw that in because a lot of serverless stuff isn't just for application, it's also for automating what we do on a day-to-day. And PowerShell is great for that if you're already in the Azure environment. Just use Python, it's nicer. A bunch of other public previews, template support for logic apps, which is again a bit of their PaaS offering. Haven't used them much, but it's relatively interesting. And one that I do like is out-of-the-box monitoring dashboards. The reality is we can create a bunch of wonderful stuff, but if we can't report metrics on it, the powers that be are not going to care about it. You want to get metrics out straight away. And then finally, the last two, which are a few GA events. We've got dedicated log analytics for application gateway. Again, more input, the more you know. And navigate your data easily in Cosmos DB Data Explorer. All that is that you can now, I believe Cosmos DB is their NoSQL platform for Azure. You can view your data a little bit easier because if you're using a NoSQL workbench, it may not be the same. Now, I'm an AWS guy, but I'm really excited for this next one, which is GCP. I've kept it short and simple because they don't put a lot of their announcements out, but Cloud Functions now support NVIDIA L4 GPUs. So you've got serverless GPU compute in the cloud. Finally. Everyone thought AWS would want to do it. They didn't. Google came first. Cloud Functions are more containers running serverlessly. AWS has Fargate. They still haven't done it. Nonetheless, serverless compute for GPU functions. The reality is if you're using anything that requires CUDA-based support, you can now do it in bursty workloads on GCP. That's huge because that functionality is not present on any other cloud provider. Some smaller cloud providers that provide like container services have that, but none of the big three. The fact that GCP is of the big three and has it, that's massive. And then another interesting one. Anyone here use NoSQL on a day-to-day basis for the applications? I'm getting a few nods. Could you imagine using SQL to query NoSQL? You can do that now in Google in Bigtable. So you can actually query your NoSQL. Now this is where it's going to get probably expensive because you have to bake the logic in. You can query NoSQL databases using standard SQL, which means that you can effectively start creating your many different joins across a NoSQL database. Again, user beware, it can probably be very costly if not done right.
Yeah, what would you do that instead of using other?
Analytics. If you're trying to basically get a bunch of analysis for a very basic application, it could be, for example, like session state. You detect someone's doing something dodgy. If you're not completely aware of what you're doing, or if you're not using a platform like Databricks, but you're a SQL, you know SQL as a base agent, because who doesn't know select star from, right? You would use something like a SQL-based query for NoSQL to figure that out. But anyway, serverless GPU compute, it's out. It's not just Kubernetes that has it, and obviously not serverless. And then in general news, this is one that we've thrown in, scan away. So the first one is that there's a wonderful, wonderful, wonderful company called Baseline, based out of Wollongong. They've got their own open source framework for serverless, built on the serverless stack. It gets you running with serverless relatively quickly. They're also baking their own DynamoDB SDK, which is actually quicker than the AWS one. And also if you're a startup who's looking at some funding, if you go to Baseline, they're actually working with Amazon for the 10K startup funding. So reach out to them or come speak to me afterwards. Next, serverless stack. They've got their own AI stack now. Here's the thing, you could probably do this yourself, but if you want to get it done quickly, if you want to get a proxy for what they call Bedrock out, and you want to get it deployed using infrastructure as code, scan that link and it'll take you to a lovely little location on how to do that. And then finally, SST v3. So I've got a blog that I've created for how to use the serverless stack to create simple page apps and then put some serverless functionality. That was with CDK. SST has officially moved away from CDK. They're using their own engine with Pulumi. So it's going to become to a point where it's completely multi-cloud as well. And the best part is you don't have the slowness of CloudFormation. But it's still native to your language. So if you're writing in TypeScript, you're going to be using infrastructure as code as TypeScript, and same with Python and so on and so forth.
So what SST stand for?
So serverless stack v3, and Ion is their product. That's this one.
But is that related to that stack or
No, this is just what that product's actually called. There's people who make serverless frameworks get a little bit confusing sometimes because you've got serverless framework, serverless stack, all have the same effective names. But anyway, you're not here to listen to me. You're here to listen to the main event. Ilya, who's up first? Is it?
I think who's going to go first?
Carl Lee.
Go first, yeah.
Great, so our first speaker today is Carl Lee, lead consultant at Mantel Group. He'll be speaking on multi-cloud usages of Lambda. So, Carl, mate, on to you.
There's also change on the SAM on the AWS side.
Yep.
To integrate with that on the Cognitive. So that's also on the serverless side that they have implemented more on the authentication, integration with that on the SAM.
I'm a fan of SAM. I like the shorthand side of it. I especially like SAM because you can use it with the application composer.
Yeah.
So
Even
is
adding
that?
to SAM is very big when people
Yeah,
deploy
I just don't like Cognito. I've seen too many things break with Cognito, so I'm just very cautious.
Then what should you use? If you have a
Okta, Auth0, there's a bunch of others. I'd rather use Entra ID. So Azure's application. Yeah. See too many applications fail because people have all these settings coming up, and Cognito is usually the case.
Yep. Thanks everyone for coming. Little introduction for myself. My name is Carl Lee, lead consultant with Mantel Group. Forte, yeah, DevOps makes things simpler. Been in the cloud for probably 5 or 6 years. Before that, in the telecom industry, which there's a lot of things that in the data centers and then like cold out and hot out. I'm pretty sure that some people here have been to those experience. It's Amazonian, and then when I was there, I was in the support group, and I'm also a cloud formation SME. So, also just to mention sponsors, Mantel Group. And then have good pizzas and beer, and hope everyone enjoy the time here. Talk about multi-cloud tasking with serverless. So real-world problems. Let's say someone asks you to write a script, go to 3 clouds, or the AWS GCP and Azure to say, okay, I want to know how much I spent per month for last month. Now, what do you do first? Probably say, okay, I'll need to talk to the cloud admin group and get the credentials, right? So that's usually the first thing, otherwise I wouldn't be able to make API calls. Now, next question is like, how do you handle those credentials? Where do you store it? Right. Put them in the code, right? Easy. No, don't do that. Don't do that, please. But this is actually like, it sometimes happens actually, because probably you know that people have run program to just scrape those credentials and do their Bitcoin mining, which happens. So first thing probably for Lambda, AWS Secrets is probably the first thing comes into mind. Now, I probably raise a question and say, what's not so ideal with AWS Secrets? If you search the internet, probably have a thing that not rotated regularly, and then sometimes like you see people with admin rights, you can go in there and say, okay, reveal secrets, and that's it, and then copy it into your notepad, and then like someone can basically retrieve that. Also, because it's so well known, if there's a breach, attackers basically try to target the AWS secrets for credentials. And also I've seen it multiple times, like when you have to reuse secrets, you basically have to replicate it through to different regions or different accounts. You basically run Ansible, for example, run Ansible or run a GitHub action to do a loop and replicate that. So how do you score those secrets? You probably use Ansible encryptions, put the secrets in GitHub action. That is still a risk, right? Because you basically have to use another method to encrypt it and then run a CI/CD to actually deploy it. So what I'm proposing here, which is an alternative solution, is Hashicorp Vault. So what is it? Just quickly, it's a centralized cluster secrets management system to basically handle your secrets, handle your database secrets. You can do certs. You can authenticate it by human, like username, password, or by a role. It's also provide lifecycle management for secrets, so it's basically rotate and short-lived. So you can set it, say, a Lambda, for example, we say 5 minutes, and then that's it. You use it for 5 minutes, and that's it. That's basically revoked afterwards. So like Vault, I think the most well-known one is their database. I think they're probably one of the best one to just like, if you, let's say, have a container, you want to authenticate to a database, they did it really well. You can have it say 5 minutes, get your what you need, and then they basically revoked. They done it really well. There's a lot of them scale very well as well. But today we're just going to look at the cloud secret engines, basically GCP, AWS, and Azure. So we're going to specifically how Lambda authenticates to Vault and then retrieve credentials from those cloud providers. So how does it work from a Lambda point of view? So this diagram pretty much shows it's like the Lambda have an execution role, which is like a standard way that you have a role. You authenticate the Vault, and then the Vault gives the token back, and that token have a policy assigned to it. Say, okay, you can only retrieve those free Lambda roles or credentials from those paths, right? And then you can set TTL. So basically authenticate it. Say you can only have 10 minutes to do your stuff. Once it gets the token, then it can retrieve it via those paths, and then it comes back with a secret. So for example, I want to grab the secrets for the Sandpit account in AWS, then that's actually what returns SS keys, secret keys, and a list duration, which in this example, it's 10 minutes. Yep, that example before is, or they call in a Vault terms, it's called the off method. They call AWS off method. So the role can be on an EC2, it can be on a Lambda, it can be on the container as well. Basically, it checks the Lambda ARN and also check the unique identification ID of that role. So you can't really botch it or try to actually cheat your way to put like ARN Lambda strings to it, because it basically have a unique strings to assign to the role. So we check that as well. If you want to know more, that's a QR code for the Hashicorp tutorial. Yeah, this is an example of what I just said. Once you actually configure the off method, and then if you do a query, it does abound the principal ARN, and then you see the principal ID, right? So those ID are unique. So let's say you actually, if you if you removed or destroyed your stack about with that Lambda role and then you recreate again, the principal ID will be different. Right? So it can't be cheated. It's always unique. And then in here, in the example, I have a policy called multi-cloud assigned to it. So you can set up different policy, super user or read only, and et cetera, et cetera. Yep. So authenticate part on the top part has been done, and then the second part is basically set up the secret engine for each provider. So it looks a little bit like this. A user or a machine can authenticate to the Vault, and then Vault actually gets the credential from those cloud providers.
So the vault itself is sort of is for the tree.
Yeah, it's a centralized thing. You can set it up as a cluster or development cluster. You can do it like multi-region as well. They have replication. You have to treat it as infrastructure though. Yeah, which is different, but I don't think it is more effort or less effort to put it this way. It's probably an alternative method.
But it's related to the role as well, isn't it?
Yep, it is. Yep.
And it is going to support even the on-prem, like a hybrid cloud?
Yes, yeah. If you want to assign it on-prem, there's an auth method called I think called application role. So application role have a it looks a lot like SS key and secret key, and then you basically assign it to it. And there's also another thing called Vault agent. You can install the Vault agent in your on-prem virtual machine. And that Vault agent can have a little store that actually store the credential in there, and then they are encrypted as well, which actually solves some of the problem when, let's say, on-prem VM could not actually make an API call. That's probably a way to do it. Yeah. Yep, AWS Secret Engine, once it's set up, then it will generate an SS credential dynamically. So let's say this example is basically generate a credential for the Lambda role, and then you can see that the SS key and secret key comes back, and then you have a list duration for 10 minutes. Now, in terms of how it's set up, the Hashicorp tutorial is pretty good. It's actually on the QR code. I basically follow it. I'm not really a Vault expert, but it's pretty. The example is pretty good. That if you go through it, you should be able to set it up.
And that will be specific for AWS. It won't be equally for the other three.
Yeah, the other one, the next screen probably will be GCP.
So you have to do one by
Yes, you have to do one by one. The secret engines, when you try to enable, they would say Vault enable secrets AWS, and then you can put a path, let's say SendPit 1 or SendPit 2, development, prod, pre-prod. They basically identify this path. Yeah. But the root one is usually, I would definitely recommend say AWS, and then you have some sort of environment, and then you name it. So for this one, it's like SendPit 1, you probably have GCP / pre-prod or prod or et cetera, et cetera. So you actually have a path, have a kind of like a path definition for everyone to use. And then once you actually set it up, then developers basically know how to use it. They don't have to worry about.
GCP, you can get access to the phone?
GCP access to the phone. I think you can use username and password if you do it from phone, but I would probably set the time to live as little as possible. You don't want to do it. Yeah. Also, Vault also have the one-time password as well, one-time code, secret engine. So I believe quite a lot of company actually uses Vault to actually just generate, say, one-time passcode when you want to authenticate and say, okay, put this 6 code in for a second factor authentication.
And this key algorithm is the encryption at rest, kind of the RSA 2048 that it is there. So that is typically for the secret keys that you have vaulted to be encrypted.
This one is Google Cloud. I think I just have it as a just default, but I think by default they encrypt it in that key algorithm. Yeah.
Use that 256 RSA algorithm.
I think you can specify it if you want to. I just keep it default. That's actually just following the tutorial, and then it just come back. This is probably more like just information of, okay, what's the key algorithm from Google Cloud. Yeah. And the same thing goes for Azure, which actually comes back with a client ID, client secret. Yeah, and then QR code are there. There's a tutorial on how to set it up. I took more time for me to set up GCP and Azure. That's for sure, because like sometimes I have to get my head around on how they authenticate and how they use those keys. All right, once you set up, then the Lambda code, which we all love, and it's actually much easier than I thought, because Hashicorp actually released different libraries for Vault. So I think Go is actually officially supported, but Python, JavaScript, and Java, they are community supported. I use Python, and they widely used. They were available from Pi as well. So basically, you load it up, and then you, for example, this code basically just say, I want to authenticate to Vault. Those three environments, they basically the default keys on the Lambda when you assign a Lambda role on that. And you just specify the Vault URL, and usually it comes with HTTP if it's a development environment, HTTPS if it's like you have to set it up as production, you have HTTPS, but 8200, you set it up, and then it just basically look for that URL and authenticate to it. Yep, just a bit of a code snippets about the functions. So once you authenticate it, the AWS side get the credentials, which and then the last part is basically use Boto3 and load up the client and get the cost for last month, and then print it out. This is a GCP part, the same thing. Get the GCP credentials, and then there's a code base to get the last month bill. Now GCP is slightly different. You have to first export it to BigQuery table, and then you actually query the table on that. So it's part of a big data service they use in order to query your monthly spend. I haven't include Azure because the code is a little bit long, so it would be a little bit too small. But if you're interested, this is the code base on that. So what's been shown, you can reuse it. I'll put a note on that. That's for demo purpose. Don't use it for production. All right. Putting all together, right? So I'm just gonna do a quick demo. I have this deployed as a CDK stack. Got a Lambda, got a event that does it monthly. The function is there, authenticated Vault, and then get the whatever cloud credential, and then do the function of last month bill for each provider. Once it's get it, then there's a common function, grab it in 3 lines, send an SMS to email. So I'm gonna quickly run it. So that's the code that I've just, it's basically what's on the slide, and that's the Azure one. And at the end, there's a send SNS, which like it's just a simple couple of lines code, and then you put it together. Right. So I'm just gonna run it. Takes about 45 seconds, but while we're waiting, any question? The email should come through on this one. So we'll in a minute or so.
This is actually meant for the budgeting. Your problem statement was how can
Yeah. So like someone just say, oh, okay, I'd like to know how much I spent for last month, right? So that's still a real world problem, but you can do whatever you want.
Yeah, if you have stored your credential using the Hashicorp and
Yep.
you're retrieving them through the Python,
Yep.
you can kind of do anything
Yep.
which is common across.
Yep.
You can use the throttling
Yep.
parameters, you can kind of
Yep.
get any insight
Yep.
which is common across.
Yeah, one of the good things for developer point of view for using this is actually they only have to remember the path. So someone would probably have to write a documentation on how the path are defined. But if they define the path all right, the developers only require the path. They don't have to say, oh, okay, which secrets, which region. Or is the secrets replicated to that region? Is it in AP Southwest 2 or is it in US East 1, right? So all they have to remember is just like /AWS /whatever account and /whatever they want to use. And this is just an example, like a real world example of like, okay, I just want to do last month, but you can literally do anything you like. Yep. So that's the email that's just got through. The Azure one I did not use any, so that's $0. But like, but that's just what you get. This is the first account. That's our SandPit. That's not my personal account. The GCP one is also our SandPit account. The Azure one that I use my private one, which I didn't use much. Yes. Yep. So that's what you get in example. Let me do a slide. So, how do we get started with Hashicorp Vault, right? I think the easiest part is just sign up with HCP, Hashicorp Cloud Platform. The QR code is there. It is actually quite good. And I think they haven't done enough marketing on that because I basically just say, okay, let's just see what it is, because my Vault, when I did it like 3 months ago, it was like from a CDK stack. I basically deployed it in our SandPit account, have a CDK, and then use open source to do it. But then I followed look at the tutorial, so okay, all right, Hashicorp Cloud Platform, and sign it up, get it set up. 10 minutes later, then I already got a Vault development cluster in, and they get $50 credit, US dollars. It's about 4 cents per hour. So if you run it 24/7, it would be 2 months. And a development cluster is probably able for you to do maybe 25 session or get at the same time. So it's more than enough for just to play around. Yeah. And then I basically use it a little bit and then stop it. So if you want to stop it at night, then you actually use it more than 2 months. All right, so yeah, definitely give it a try because it's free. Yeah, the second one I mentioned, open source. That's the Vault CDK code that I use to bring up the stack. So give it a try. Not for production, but definitely it can be used. All right, the boring stuff. For production, because you have to have privileged access keys to be provisioned to the secret engines, make sure that once you get it in, rotate it. So once you rotate it, only Vault knows it. And then you cannot actually look at the root credentials. Yeah, root token, when you initialize the Vault configuration, it has a root token, which actually is a super user token. Once you get that to set up all your engines and off method, the recommendation is revoke it or just not use it. Yeah, clear policy, those are the main thing. Once you have a security infrastructure, you have to have good communications and also have a methodology to actually manage it. And then my recommendation is not really only have one group of doing it. It should be a code on, because you don't want some group to use it as a kind of like a weapon in a way, like within the organization. Say, okay, right, we're gonna hold you. We're not gonna give you this credential or path or not provisioning it. So communication is very important. Also, let's say a production cluster, you have replication going on. You do have to actually perform failover test and etc. and backup and restore just to make sure that that infrastructure will be fine if there's any fault or downtime on it. Yep. Conclusion. I think security-wise, it's actually enhanced security, Vault. It simplified management for multi-region. In my opinion, better developers' experience. Yep. Also, very easy to get started. Either you use open source or sign up with the Hashicorp cloud platform. And then there's a wide selection of method and secret engines. If you read a little bit more, it covers a lot, even Alley Cloud, it covers it as well. Yeah, it is, like I mentioned, important thing, which is also boring stuff, is this centralized secret and encryption management system. So treat it as a really crucial business infrastructure if it really has to be, you want to use Vault as production authentication and secret management. Yeah, and then finally, make sure that like it's code on by different team, not just one single team. Yep, that's it for me. Any questions?
So it can be set up at any time. It doesn't need to be set up early on or.
It can be set up at any time. I think the Hashicorp cloud platform is probably the best way, because it's actually set up in their own managed environment. And then let's say you want an internal, and they also you can actually peer the Hashicorp cloud VPC to your VPC. So your private infrastructure, which actually cannot go out to internet, if you peer it, you can actually authenticate to the Vault, which are in Hashicorp cloud. I'm surprised actually how good and how feature rich and that like. Sorry? It's IBM. Yeah. Now it's IBM.
It's not a bad thing. Red Hat is still good.
And we haven't heard about IBM so far for many years.
Look, I mean, some people might actually say, oh, IBM, but like I don't underestimate IBM. They've been around like forever. Yeah.
Yeah. Any other questions?
I understand it's like an edge case to use Hashicorp, and in this specific scenario, I would consider also to use OADC connection between clouds to avoid extra party, and it solves the same problem. So you can use OADC connection to have token and perform.
Definitely, yes.
Hashicorp is much more use cases.
Much more use cases, yeah. Their database is actually very, very good. Because that has been talked a lot about the dynamic database credentials. I talk a little bit less mentioned, which is the cloud one. But if you have it, you probably almost like you can do 80%, 90% of what people want to do. Like renew certificate is also another thing that they can do very easily. Yeah. Yeah, if you are production, then you actually set the TLS certificates on that, so it's trusted. And then you can also restrict a certain URL or subnet to actually get access to it. If they doesn't match, it's actually blocked. My developer cluster basically is very wide open. So, but for production, they have a way to set it up so you can actually just say, okay, we only bound to certain subnet, and then only that subnet can access it.
Any other questions?
Did that.
Alrighty, thanks everyone. For those in line, we're going to be taking a pizza and beer break. I suggest you do the same. Grab an Uber Eats or something. And we'll be back 7-ish. Don't hold me to that. See you guys soon. All right, everyone, grab a final pizza, grab a drink. We've got the big talk of the day coming up. So in about a minute or two, we'll be kicking off the next conversation. Again, just grab one more drink, one more slice of pizza, grab a seat, and we'll kick off the final talk of the day. I think we're good to go. There's a couple of stragglers, but you know what? They miss out on the good stuff. Over to you.
Thank you. Okay. Final checks. Hey everyone. So, what first comes to mind when you hear in serverless? At least, and yeah, maybe S3, SQS, DynamoDB. Okay. I do bet that no one thinking about the Kubernetes when it comes to serverless. And I realized that it could be my first and last presentation in this serverless group, presenting Kubernetes. But let me try to convince you that it's worth it. Who am I? I'm CTO in an open source company, and we are partners of AWS. We are helping our clients with migration to AWS, with cost optimization, with all the stuff they need help. I'm Ukrainian. It can explain my hard accent. I started as a system and network engineer back in 1996. And at the same time, I have 20 years of experience in automotive business because it was a family business I helped to run. So somehow, AWS on a dedicated serverless page has only 17 serverless tools. And I hope you know most of them. Some of them are debatable, like Aurora Serverless, just because it can't scale to the 0. Some we are using every day. We can't imagine any infrastructure on AWS without S3. At least I can't do it. And some quite niche products, like Neptune database. It's a graph database. It's started to be popular with the boom of AI. AppSync, another application, another service which is new for me. It's GraphQL alternative to the API gateway. It helps to work with your GraphQL applications. SQS, well known. Redshift. But only Fargate can make this speech related to the Kubernetes. And even we have only 17 services on this dedicated serverless page, there are many other serverless services on AWS. We can call them, it's Bedrock, it's also serverless. If you go to the Bedrock page, they mention that it's serverless, fully managed by AWS. It's Kinesis streaming service. So there are much more services which we can call serverless. I guess there are only engineers. How many people here engineers? So it would be safe to say that we are a bit different to people who are working in a creative sphere. Because there are such things like Einstein effect and functional fixedness. It's such cognitive bias when people locked to use one tool specifically for what it was made for. But from my observation, I, as engineer, and all other engineers, I guess, we are guilty in overgeneralization. Once we learned something, how to use it, we're starting to use it everywhere. Doesn't matter. It's a good fit, it's a bad fit, it's a tool we're mastering in, and we're starting to use it everywhere. Programming languages, services, call it yourself. So let's talk about the 3 compute services AWS provides as a serverless, and my very opinionable understanding of their pros and cons. Lambda, we know that in a pros we have scalability. It can scale very fast. It can run as many copies as you need. It costs just fractions of dollar. Depends of how long it's working, but comparing to other services, it's really cheap. It has a lot of integration with many AWS services, and it's working as multi-regional out of the box. On the flip side, we can see that it's 50 minutes runtime execution. It's a well-known limitation, and it's great that we have this limitation, because without it, we will have even more strange use cases when engineers using Lambda. It still requires some, it has requirements to your application architecture. So your application must be cloud native. You need to make it to work effectively in Lambda. And the best fit probably it's event-driven applications. When you have some trigger, you have short-running task, which sends the result somewhere to the database, to event bridge, somewhere else. And vendor lock, I'm not quite sure if it's a case for Lambda, just my guess, that I have never tried to migrate any Lambda-based application to the other cloud, to Azure functions or Google functions. But I guess it will be quite complicated task to do it. ECS Fargate. So ECS, it's a managed AWS service which helps to run containerized applications in AWS. You can have either EC2 for run your ECS, but because we are talking about the serverless, we have such service as Fargate, which give you a chance to run your application in AWS Cloud without having to manage any virtual server. Pros is scalability. It scales pretty good. It's again have good integration with other AWS services. And comparing to Lambda, it has better resource, more granular resource allocation, because in Lambda we can adjust only memory, and based on the memory we can have more CPU and other resources. But in ECS we can adjust both CPU and memory requirements for our application. For cons, I put higher compute cost comparing to EC2, but it's understandable because someone else doing your work with patching, updating all these virtual machines. Its managed services, it's always managed service cost more than non-managed. It's still some requirements to software architecture. You can't just run any application in ECS for RAID. You still need to have it at least containerized. And it's good if it follows these 12 patterns of good containerized application. And again, it's vendor lock, not about the container itself, but about all the configuration you are doing, either with CloudFormation to define your task, or with CDK, whatever you are using, or just clicking in a web interface. It's not recommended way to deploy your infrastructure. It will be some vendor lock. And honestly, I gave a try to ECS many times, but every single time, I have to fall back to the EKS because of some limitations I met. And these limitations was out of my control. It was on the application side, and I just unable to convince developers to fix it, or they just don't have, they don't have time to do it quickly enough. So coming to the EKS. EKS, it's a managed AWS Elastic Kubernetes service. AWS provides you with a control plane. Probably the hardest part of Kubernetes is to maintain this control plane, because there are several critical components such as API running there, and AWS does a great work providing easy way managed service for control plane. You can connect your worker nodes to the cluster with managed AWS groups, with self-managed groups, individually each virtual machine using such tools like Carpenter. But another option is to use Fargate. The same way as with ECS, you can just create Fargate profile in EKS and then define in your application that you'd like to run this application on Fargate, define some resources, requests, limits for this application, and it will be deployed somewhere by AWS, and it's totally serverless. So what is the pros for using EKS Fargate? First of all, it's Kubernetes native. So you literally can run any Kubernetes deployment in EKS. It provides great scalability. The biggest advantage is variety of Helm charts available. So I don't know if anyone can recall any big product which provides CloudFormation template or something else to deploy their product on AWS. Normally, it's just Helm chart. In rare case, it can be customized. Another way, it could be even some YAML files definitions to run application in Kubernetes. But I have never met other options, like you can take this and run on ECS, or take this and run it as Lambda. And last one is EKS provides less vendor lock comparing to Lambda and ECS. Just because this Kubernetes native part, we have definition of our Kubernetes components, and they will run everywhere in Azure, in GKE, in self-hosted Kubernetes cluster. From the con side, I want to mention that it's definitely overkill for simple workloads. Nobody will say you that it's effectively to run some, I don't know, proof of concept, some small application, and you will need to deploy it straight to the EKS. It's much easier if you are developing new application. Please consider Lambda. It's a great way to test something. And if it's some modern application, it probably will be the better fit. But if we are talking about migration from on-premises some legacy applications, it will be much easier to run this application on EKS than try to adopt it to ECS or Lambda. Additional, it's a cost of the control plane. It's $72 per month, but probably it really relates to the first point that it's not for the small projects. Because Lambda you can have for $1, $2 per month and your application will work. Kubernetes will cost you at least $72 per month only for control plane, where you can't run any workload. You will also pay for Fargate to have any workload there. It's definitely steep learning curve because there are many different concepts you have to learn to understand how to work with it. But probably it's worth your time. You can use this knowledge later. You still need to learn to deploy something to Lambda. You still need to learn how to operate ECS. And last one, it scales slower than Lambda. There are several tricks we can do to make it scale faster if we have budget for it. But honestly, yeah, it scales slower.
And you need budget.
Yeah.
Anything's quicker with money.
And if we're talking about the cognitive biases I mentioned before, I understand that it's really opinionated list of pros and cons, because when I made it, you need to understand that I am working with Kubernetes for last 5-6 years. I have plenty of snippets for different kind of projects. I have everything defined in Terraform. I understand how it works under the bonnet, so I understand it's easy for me to troubleshoot. And another cognitive bias, it's confirmation bias. So every time I can see over the internet such things. It's Figma who telling us it was this month or last month that they spent 12 months for migrating from ECS to Kubernetes. Another company doing migration from Lambda to Kubernetes jobs. And our brain wired the way that we have this confirmation bias. So we always see confirmation of our opinionated ideas, and we need to try understand where it's reasonable to use some tool, or you just fall in these different biases just because you like this tool, you know it. And the best example of such biases is a phrase that if a person has a hammer, every problem for him is a nail. And we are, as good engineers, should always know that best practices and when to apply them. As I mentioned on the beginning of my talk, I was working in automotive business. And we were a dealer of Skoda cars. It's Volkswagen Group. And the best sales pitch was to say clients that everyone from the owner to each employee are driving a Skoda car. It was so easy to sell cars using this as an example. And it's the reason why I was driving for 20 years different models of Skoda. And when we sold our business, a lot of variety of different brands started to be available for me. And I gave a try to Lexus. I bought Lexus, I started to drive it, and every single thing in this car started to annoy me. Every button not in a proper place. Every turn of the steering wheel, I do not feel the same feedback. And does it mean that Skoda is better than Lexus? No, definitely not. It's just because our brain built the way that we used to use something, we adopted to it. Our brain built these neuron links, and we moving and moving the way we like to do. And there is a difference between a good engineer who knows the best practices and when to apply them, and the great engineer who knows all the best practices and when not to apply them. Because not every tool is good for every situation. Questions?
Have you used Knative?
Yes.
So would you say that's serverless on Cube? They sell themselves at that.
Yes, but you still need to maintain it somewhere. So it's still serverless, but under your control. So on which side of infrastructure you? So if you're a developer, yes, for you it's serverless on Cube. But for me as, I don't know, DevOps engineer, infrastructure engineer, SRE team, it's just another product I need to support to make it highly available, to troubleshoot it, to upgrade it. There are still some servers.
It's an abstraction more than anything else.
Yeah, and it's probably really hard to start from the top of the abstraction when you're learning something. I'm happy that I started so many years ago, and I learned it moving to the top level of abstraction, understanding all what located behind. But now, when you're starting from the top, you still need find the time to go on the lower level and learn what is happening there, just to better understand.
Any more questions?
If anyone wants to change my mind about the ECS, just get in touch.
No, I think everybody agrees. Cool. All right, thank you very, very much, Dmitro. So, we've had a lot of opposing thoughts here today, and we've actually smashed all the pizza, so thank you all for making my job a lot easier. So that'll be it for today. We'll have a couple minutes of networking left over, about 15 or so, before they start calling security to kick us out. So thank you very much for joining today. We run these every 3 months or so, so if you happen to want free dinner, or if you want to come chat serverless, anything compute, or if you want to compare why Cube sucks, it's actually all right. Calm down and come have a chat. Thanks, everyone.